Hi, I'm Tom and I talk about code. Welcome to another PlayStation 2 development stream today. I'm doing this intro for the second time for all the wonderful people on stream. Today, we are going to be doing more sprite work, more graphics, making our game more beautiful. Last time we did some cool stuff with sprites. We got sprite rotation, it's looking very fancy. I've done a little bit of work off camera. Let's have a quick look at where the game is. Okay, so I drew a player sprite. It's kind of ugly, but it's kind of cute as well. Little spaceship. You fly around, you shoot. Again, I updated the rock graphics. Again, I'm pretty sure I did that off camera. So we have something that resembles an actual game now, which is so exciting. Okay, it's been months. It's been months in the making. And we can finally build cute little things like this. But I want to make this a little bit nicer. Okay, I want to see if I can push this a bit further. The main way I want to do that is by making a background, right? We're meant to be, in space, a spaceship shooting... I don't want to say asteroids in case I infringe on some copyright, but, space rocks, okay? Serious business. So let's see if we can make the background nice. I need to readjust my microphone a little. God, still working on a microphone stand, okay? Still on my list. Still on my list of things to do. Okay, so I've drawn a few things, right? I'm imagining we're going to have some little planets go past in the background and maybe a few twinkling stars to give us some atmosphere. Maybe some like cloudy, dusty masses as well will go past. We'll see if we can get to that. Actually, let's add one in here, right? Because I'm not very sure how transparency is going to work. So let's go a nice low hardness brush. How can we draw a mostly transparent color? Can we... So let's just put like a little puff in here. Let's maybe select the area so we don't go outside the bounds. Let's go... Whoop. And then can I just like maybe erase over it with a low... Can I just like... how do I do it? Hardness? Do I turn the hardness down? No? How do I make something very transparent? Opacity, that's the word I'm looking for. That would do it. Okay, let's do that again with much less opacity, right? We're just gonna have, I'm gonna turn this on so I can kind of see, we're just gonna have this faint little wispy mass. Okay, and that's something that can just kind of like glide by in the background and give an air of texture, hopefully. I'm not really sure what it'll look like when we try and draw it. It may come out completely untransparent, okay? But we'll get these in, we'll set some colors, we'll do some fun stuff. I'm currently drawing the player and the rock from here, so if we have a quick look at our scripts, I've got my asset loader. I can actually clean these up. These are gone. We're doing this all from one sprite sheet now. And if I delete those, that should have no ill effect to the running game. And it doesn't, everything's still there. Perfect. So we have one sprite sheet. I had these separately before, but these things, you want things in one sprite sheet. In the PS2, we have this limitation of 64 by 64 textures, so basically this size is the smallest thing we can load into VRAM at once. So if we want to draw something small, we've got to make it part of a sheet with other things. So that was basically why I've started stitching stuff together. We've got a fair bit of space here to do some other stuff with. Maybe the player bullet, can reuse this graphic or something. But we're going to start by drawing a planet, the first planet. And the first thing we need to do is work out the actual coordinates for this. So obviously the top left coordinate is going to be 0, 0, and we're dealing with things in this scale we dealt with last time. Okay, let's crank our opacity back up. Let's crank our brush size back up. Let's crank our spacing back down. There we go. Okay, so we've got this coordinate system where 0, 0 is the top left and 1, 1 is the bottom right. And so we're going to have things that are like out here, right? We're going to have to calculate some funny little boxes and work out what the bottom left corner of them is. So for this one, we've got a grid that's 16 by 16. This whole image is 128, so this is 32. So if we go... let's get Python up, 32 on 128. I should be able to do this in my head, but I can't. It's a quarter. It's a quarter. So let's go planet A. The top left corner is going to be 0, 0, and the bottom right corner is going to be 0.5, 0.5. Yeah, perfect. So similarly, this second one, planet B, the top left corner is going to be 0.50, right? Because the x is the same x as the end of this one, but the y is still 0, and then the bottom right is going to be, 0.25. Almost had a catastrophe there. So the bottom x coordinate is going to be 0.5 here, because this is halfway across the image, right? So we're selecting this box. So 0.5, 0.25. Awesome. So we're gonna need something new. Let's go script entity planet. And maybe a planet just kind of scrolls past in the background, right? Nice and simple. So let's go. We grab our entity script, that's entity.entity. We define a new entity in our system, and it's pretty simple, right? We have a position, and that's pretty much it, right? It's gonna let's just have a position for now, right? We'll just have a couple of planets drawn on the screen, not doing anything. Sounds like a good place to start. So. Function planet draw. Actually, I reckon they should have a color as well. Let's go col equals m.vec3 0 0 0. Maybe 1 1 1, right? Because this is going to be a straight white color. We need to include our math library as well. Cool, okay, so let's draw 2D. We need to include draw 2D as well. Local d2d is require draw 2D. I'm swapping over to require without brackets. It seems to be much more idiomatic Lua. I think I mentioned this last time. So, draw 2D, set color. Let's go 0xff times self.col.x, self.col y. Right, so we've got this vector 3. We'll have the elements of this between 0 and 1, and we'll multiply them by pure white to get a final color. Cool, and then d2d text try. We want to draw a triangle texture. Actually, no, we just want to draw a sprite. That's okay. We don't need to do the triangle texture thing. On the PlayStation 2, as I've talked about before, sprites are axis-aligned boxes. So if we just wanted to draw the player like this, we would use a sprite. But if we want to draw the player rotated, so he can face up, or he can face, at some weird angle like this, we need to do it with two texture triangles. So here we can just use a sprite. We can grab the sprite sheet. We go pos x, self, pos x, self, pos y. We give it a width and a height. Let's go 32 by 32. And then we give it the UVs. So these are, we've got a list of them in our asset file, planet A. So index 0, 1, 2, and 3, or 1, 2, 3, and 4, sorry, Lua's one indexed for XY, XY, or ST, ST, I guess. A little bit confusing. Kind of have to unpack our formats as well. So let's go a.planet A0. This should be 1. Yeah, this is a very confusing packing. Very confusing packing. I don't think you could have a more confusing packing. And then we need to just return planet at the end, because you return something from a Lua script. That's kind of, if you you define a class in a Lua script, you return that class at the end so things can use it. You define things in a Lua script, you have to return something out at the end that exposes the things you've defined. We also need a function to make a planet. So function. Oh, sorry. Let's go planet.new. That makes more sense. No curly braces here, unless you're in table definitions. Planet new, set meta table, pos. Is that how we do it in player? It is. That's how we do it. Alright. So we've got a planet. Let's go into our game. When we enter the game, let's go self, spawn, planet, new. And let's put the planet at 100, 100. That sounds like a nice place to start. So let's go is require entity planet. So what happens if we run this? Does it work first time? Probably not. It blows up. That's okay. These things happen. We're going to lint our Lua files. We're going to see what it says. It's actually pretty happy. Okay, well that's annoying because that's actually harder to track down, right? This is a more subtle error. It's good. It means we didn't make a dumb typo, but it's bad. Entity planet. Okay, so something blows up when we try and include the planet file. I suspect I know what this is. I suspect I know what this is. We haven't, first off, we're using something. Entity define, entity require, entity. This is okay. We're using this, and we have not included this. I don't think this is it. I don't think this is it, but let's see if something different happens. Yeah, it still blows up. And I knew that wasn't gonna be the case because this fails when it tries to include the file. Right? It happens way up here. If we look at what this would have, where this would have crashed, it would have crashed in here when we're trying to actually reference it. But the draw function doesn't get called until well after this is well after this file is loaded. It doesn't get called until after we've spawned things in, instantiated, whatever. So entity.define. So some syntax thing has gone very wrong here. PS2 math, draw 2D, entity.entity. This all looks good. Entity.define. This looks good. Pos equals bar. Planet dot. So this really has to be this has to be some syntax related thing, right? So what if I do this? If I do this, do you still blow up? You do. How much of this can I cut out and it'll still yell at me, right? So what if I, instead of entity defining, for example, what if I just do this? If I just do this, you're still angry. Still very angry. It could be. This looks very much like I've done the right thing, right? Let's try returning empty table. Let's see if it's this line. Could entity define be returning null? Right? That's the other thing to consider. Okay, so what if we put a log in here? What if we say log debug? We can actually also see this in the logs, right? The entity gets defined, and well, we're probably gonna see that it doesn't even log this. Set field rock. Yeah, so we can see we define the rock. Okay, we define this other stuff, and then we hit the planet, and it all goes wrong. Okay, we're hitting the ground limping. We're hitting the ground limping. There's probably a very obvious solution to this. Planet. Entity define. Is there something dumb I've missed? There must be, right? There must be. And there's nothing in the lint, which is always infuriating. Game.lua. What if maybe the entity manager just doesn't like having lots of things, right? Does something different happen if and very annoyingly, right? Very annoyingly, I just kind of have to trial and error it like this. Okay, no. Here it blows up, including assets. Maybe? Maybe not. Ah, I've got a suspicion. I've got a suspicion. Could it be? I don't think it is. I don't think it can be these, right? These look okay. And LuaLint would pick up if something was wrong there. So, what are we doing? What are we doing? Oh, these are the worst things to try and fix. Okay, so let's go. Engine script. Engine dist script. Engine dist script ps2 init dot lua. Require. Okay, when we require. Instead of calling true require here, let's pcall this. Let's see if we can box it. So how does pcall work? Lua 5.4 pcall. I bought the programming in Lua book. I don't know if I mentioned, right? Very good book. Very cool. Highly recommend. Highly recommend. Pcall. Let's remind ourselves how this goes. I think it says it's the same as call, right? Pcall function arguments. Okay. So let's go pcall. Hold on, it returns stuff. First results a status code, and then the thing. So let's go error pcall true require p. If error is true, or if error isn't false, right? Then so this should work. This should allow us to catch more errors. Maybe not, but we'll see. Yeah, no, it still just blows up. It still just blows up. That's okay, right? That's okay. Pcall does not always work like we want it to. And this is a bug in how setJump works. Annoyingly, right? Very confusingly. Okay. What's going wrong? What's going wrong? We're stumbling at the first block. That's okay. When we try and include this file planets. So let's go log debug. Let's just add some logs, right? Let's see if stuff happens when we try and load this file. And it doesn't look like it does. It doesn't look like it does at all. So it doesn't even get to parse this file completely. Okay? Doesn't even get to parse this file. Doesn't even get to parse it. Why not? Why not? Oh, hold on. Engine dist script. I wrote that in the wrong file. I wrote that in the one that gets overridden every time we run. Okay, let's do that again, right? So let's go R is pcall true require p. If error isn't false, then log error error what does this do? Does this at least give us a better message though? Surely, right? Yeah, it gives us something. Require no. Require assets. Require assets. Okay? Require assets. What happens when we require assets? Null. What is this? PS2 init Lua 44. Oh, hold on. Oops. True if the cause of considers. any error, pcool returns false plus the error object. Pcool returns false. Okay, hold on, I did the wrong thing here. So let's go ps2 init. Let's go ps2 init. Pcool, error. So this is the status, right? The first is the status. If this is true, then we can return the results. If it's false, then the other parameter is the other return value is the error object. Okay, so in other words, this is our error. Otherwise, we just return it. Okay, what does this look like? Yes, that's fine. We're gonna get a better message now. Okay, we're gonna get a much better message, or not, or we just get a null. We just get a null. Okay, let's add something more to this, right? So let's go log error. P and then the error, and then so let's just log everything here. Okay, let's just log absolutely everything. But of course, it still actually crashes the entire thing, right? So what do we get? What do we get? Okay, require draw, require VRAM, explode. Does script main seems to be blowing up at an earlier point, weirdly. Why do you blow up? What's happened? What have I changed? Script main, script VRAM. Okay, well let's dump this to a file. Let's dump this to a file. So what happens? We start stuff up, ps2 init, ps2 init. Open the host, script main, require, explode. When we require VRAM, it just blows up. It just dies. So what's going on? What's going on? What have I done here? I must have... Surely this hits an error, and my error handler causes a crash. Okay. So my error handler... ps2 init is trying to do something with nil where it's inappropriate, maybe. Maybe let's try this. Let's forget that R exists for a moment. Require VRAM. That's really odd, right? Like, why does this have so many issues? Why does this not work? Require... Can I just not something require assets failed, require entity failed? Why are my requires failing? Right? Why has this suddenly all started failing? What if I go into game? Okay, if I script game, and let's just get rid of planet, and let's see what happens, right? Make run. Does this stuff still fail? It should. Yeah, it cries, but it hits it. It complains at a different spot, which is concerning, right? Which is very concerning, because the game actually starts here. It starts and it hits this point. So what I think is requiring this thing here. Entity planet. Let's get rid of the debugs, okay, just in case, right? But what possible way is there that this could cause this kind of a bug, right? This kind of a crash. Okay, entity... Okay, now we're back to require entity planet. Interestingly. And it crashes here. Something. Require entity rock failed. Why do these fail? What does this mean? What does this mean? I've got to be... My logic has to be wrong here, right? My logic has to be wrong here. True if the call succeed. The first result is the status code, okay? Check this with me. The first result is the status code. That's this error. If this is true, the call succeeds without errors, in which case pcall also returns all the results from that call after the first result. So we have two results. Okay, if the first one is true, then this is the proper response from add require function. If it's true. If it's true. That's the key. I had it backwards. I had it backwards. Sometimes you just got to read it out loud, okay? I had it backwards. This no longer fails, which is good. But it no longer gets to realize that something has gone wrong, okay? So pcall is powerless here to detect whatever the hell is causing this fault. Pcall has no power to catch this class of error. This is just a nil pointer dereference. So when we try and load the file, a nil pointer dereference blows us up. What can that mean? What can that mean? Okay, so here's what we do. Let's move entity, let's copy script entity planet. Let's commit it. Add script entity planet. Yeah, sure. Ignore those secret branches. They're really not actually that secret. Okay, so here we go. I'm going to go into my engine planet. Now we can always just git checkout and we'll get this back. First off, local. Okay, that's weird. Hopefully that isn't the issue. No, good. Good. But there was an error in parsing there. So let's get rid of the requires. First things first. Get rid of the requires. This should blow up, right? This should blow up because we have a nil pointer dereference here. So let's get rid of this. Get rid of this entity define. We just have a table. We just have a table. Okay, perfect. So we know where the problem is, right? We know where the problem is. The problem is here. The problem is in parsing this somehow. So what if I get rid of that comma? Let's just like rule everything out, right? No, of course not. PS2 math. Because this gets called when we load the file, right? So if this is nil, then yeah, this is a nil pointer exception. So let's m.vec2 pause equals require ps2 math. Let's see if we can do this. And it still crashes. PS2 math. PS2 math. m.vec2. Entity define. Okay, so does this work? Even requiring this file seems to blow us up. Okay. What if I just wrap it in parentheses like I have been doing all along? It still somehow is a nil exception. But we're still using it down here, right? So what if I just get rid of this new function as well? Then it still blows up. Because we no longer have a planet. Hold on. Let's keep our focus here, okay? Because this doesn't get evaluated until... So, can I require PS2 math? Yes, I can. Okay, can I... can I print it out? No. Okay, this is promising, right? So when I require PS2 math, I am getting nothing in return. This is interesting. This is progress. Okay, this is progress. Let's wrap it in things just to make absolutely sure. require PS2 math. We hit the require and we explode. There is some null pointer exception. Okay, but we hit... PS2 init. We hit this line. We hit this line, and we know that we're requiring PS2 math. That's good, right? That's good. This seems good, right? This seems like what we want. Error not equal to true. We return R. We return R. If error equals true, then R is what we've required. So what happens? Require draw 2D, retry. But see, we're back to failing up here now. We're back to failing up here now. Make run. Okay, where are we failing? Can we at least be consistent? Yes. So if we try and put... There's something really rotten here, right? Because even if we try and log... Okay, well let's forget about logging what... Maybe let's just wrap a toString around it. That would probably stop a nil pointer, right? You can take... Yeah. Okay, there we go, there we go. Required equals table. So there is a table here, right? There is a PS2 math table. And we return from this, so let's go planet. And this explodes. Required equals table. So we never log. We never get out of this call, right? So we do this. Required equals this. Return this. Require. M is require this. But we never hit this log line, seemingly. We seemingly never hit this log line. What does it mean? What does it mean? My brain is too fried for this right now, right? Because if I get rid of this require, we actually start up. We don't do anything. We get an error still, but we get an error we can actually catch, and an error that makes sense. The minute we include this, boom, we're gone. We're absolutely gone. So what if I don't use M, right? What if I just don't even use it? What if I just... It just requiring this file is enough? No. Okay, there we go. That's interesting, right? This is something. So we can look, we can say require assets, game manager on spawn, just before this, require game manager, require text, draw2D, require planet. Here we go. It requires PS2 math, got M, blah, 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 blah. So as long as we don't try and use it, right? The minute we try and... Oh, hold on. Hold on. I'm being silly. I'm being silly. Attempt to concatenate nil value name. Game lure 45. What is this? E.name. Of course there's no E.name, right? Because this isn't a planet. So let's go entity is require entity.entity. I don't know why not wrapping this in toString was resulting in... Oh, I guess it's because my log functions are dumb, right? I guess it's because my log functions are dumb. I just try and treat things as... No, but no, this should just concatenate. I don't know what's happened here. I really don't. So let's define this as an entity, okay? And this crashes. My word. Just one crash after. Okay, it can't find entity. It can't find entity. That's good, right? This means we're making progress. This means we're making progress. entity and it stray letter, stray character. This is good. That's not good. That one I'm actually not sure about. The previous crash made sense. This one confuses me and scares me. Got entity. Okay. But when we try and use it, 194. 194. When we try and use it, there's a problem. I'm just very scared that we're somehow running out of heap space and running into garbage, right? Or there's some memory corruption. I'm very concerned about memory corruption. Because this just feels insane, right? This just feels stupid. Lualent, completely happy. Nothing wrong. But the minute we try an entity.define, this is sad. Okay, so what happens in entity define? Define. Entity define. Pairs entity. Now. There is a problem here. Okay? There is a problem here. The problem is that we try and get this name field, which is actually in this case nil. So let me go name equals planet. And this may actually be the source of all of our woes. And it is. Oh my god. Oh, that is miserable. Okay, so first things first. Entity. If t.name is nil, then t.name is undefined. Unnamed. End. Okay, first things first. Now git checkout script entity planet.lua. And we've got our planet thing as we had it before. Okay, so there's a little bit of stuff to do here, right? Let's just... Oh, that's just that weird syntax error we committed by mistake. This time it'll work, right? This time it'll work. There's no planet being drawn, but that's okay. That's okay. We will take this as a first step for now. Holy crap. Holy crap. 30 minutes to work that out, okay? 30 minutes. What error do we have? Nil field col. Where is col? Self.col. Yep, of course, because we got rid of it, right? m.vec3. This is going to be, let's give it a nice blue hue this time. So let's go 0.3, 0.5, 0.9. Now look at this go. Still a few things. Attempt to index a nil value. Attempted to index a nil value. Attempted to index a nil value. Possibly because if we go into assets, planet A, no, that's okay. Attempted to index a nil value. So call XYZ, that seems fine. Pause. That seems completely fine. Attempted to index a nil value. Now, there are lots of things that can cause that, right? There are lots of different things that can cause that. And unfortunately, we don't get a good error traceback when that happens, right? So, So. Planet set color self, a.sprite, self, a. Okay. What if I just hard code these for now? Let's go 0, 0, 0.25, 0.25. What if I run here? Attempted to index nil value, right? Attempted to index a nil value. Slot iterator error. Index 1. And then the error. So this makes it sound like we've got a nil in our slot, and maybe we do. And no, we don't though, because we return this. We return this. Game.lua. Let's get rid of the game manager for a second. We'll keep this nice and simple. slot iterator error index attempted to index a nil value. Index a nil value. Index a nil value. So let's log info draw planet. And let's just log just for interest, toString self.col. toString self.col. Okay. Let's see what this looks like. We have a color. We've got a real color. Attempted to index a nil value. What's our nil value, right? A. Is it A? What about this? Is this going to crash because this doesn't have a toString? That's okay. A is nil. That's something. A is nil. A.sprite is nil. It makes me suspect that A is nil. Right? Or maybe we're just using the wrong name. Doesn't that ruin your day? This is why strongly typed language or more strongly typed languages can be better. And look at this, we've got a planet. There we go. It draws in front of our player, and our player weirdly inverts in color when we move behind it, but there is a planet. So let's see if we can mess around with this more, okay? Because at the moment this is a little bit bleak. Can we draw it? Because there's no transparency here, right? Can we draw this with very low opacity? The answer is apparently no. The answer is apparently no. Can we change its color? The answer also seems to be no. Let's go just like pure red. Nah, no good. Ooh, how can we do this? Why isn't this working? So let's have a look at draw2d.c, right? Draw2d.c, prim ad prim. Here we go. So buffer ad prim. GIF, no. Buffer.c ad prim. Here we go. So we should, every time we set the primitive thing, we should be setting alpha. Let's go sprite. Not buffer Lua, sorry, draw2d. Sprite. So what do we say here? We say primad 010. What do we say for text try? We say 010. What do we say for try? What do we say for triangle? We say primad 000. Nothing. How do we draw transparency for the boxes? How do we do this? Player bullet. Right? Because we got this working here. Oh no, we did. We got it working with AABBs, didn't we? AABB. Did we draw them? Is that happening in game.lua? It is. Each set color. D2D rect. D2D rect. I just want to double check that I'm actually using the right renderer, right? PS2 prog.slow2d. Let's just see if anything different happens. Program died. Unexpected symbol. Because I put the word local in when it did not belong. Oh. Okay, so actually, we have some different behavior, some very different behavior in a slow 2D renderer. This is interesting. This is interesting. We can definitely do something with this. So slow 2D is a little bit more correct for now. That's good to know. So let's play with this. Let's go from this. Player Lua. I turned the opacity of my player down just for fun, just for a laugh. Because it looked a little weird. I don't know if you could tell, right? But it was a lot brighter than the sprite that I'd drawn. It was kind of like super colored. Now this is a little bit better, right? Okay, so we've got a planet. But this planet is still having problems with semi-transparency. So let me go planet, set color. Okay. So textured triangles seemingly have this. So x, y, and let's go self.pos.x plus 32. Yeah, plus 32 self.pos.y, so blah blah, and then self.pos.x, self.pos.y plus 32, right? And then we've got to do this thing, so 0, 0, 0.25, 0, 0, 0.25, right? So we're going to get a slice of a planet. Or not, we're going to get a weird line. Hold on. Oh, because the UV goes, yeah, we go X, Y, S, T, right? I did that wrong. 0.25, 0, and then we go 0, 0.25, and that's the end. Okay, so we do this again, we get something that actually looks like nothing, because I made a syntax error, because I forgot a comma. Okay, here we go. We get half a planet. But see, why does the alpha work here? Like, what's different? Okay, so if I go player, what's actually different here? Set color. What's actually different here? Let's just hard code something. Let's go. What have I done differently? Why does this not have transparency? Right? Like, surely. Surely if the player can do it, this can do it. They're drawn the same way. They're drawn the same bloody way. Set color, text try. The only difference is that the player actually has transparency, like out the box, right? But that shouldn't matter. That shouldn't matter. Sorry. What would be causing this? Seriously. What would be causing this? 80, 80. Let's draw it super opaque. There's got to be some other stuff to try here, right? Try super quiet, super dim, and that's okay. I mean, it shouldn't be drawing in front of our player, but that's not the end of the world. We definitely need some kind of like background layer, but why is there no transparency on it? Like, have we spent our transparency budget? No, that doesn't make any sense. But if I put this down to 10, we get a very transparent player, right? Or 1-0. Or do we? Maybe we actually don't. Maybe there's just no transparency here. Maybe I'm just going crazy. Yeah, that was just the color difference, I guess. Okay. Never mind. I'm chasing a ghost. Let's dig into... Oh, this is dangerous. The hardware manuals. Okay. Here we go. We're going to find the section on sprite drawing. Texture mapping process. That's actually not bad. Drawing environment. Types of Z buffer. It's going to be... Where is it? Drawing environment. Settings, registers. Drawing function. Outline a drawing function. So this is how a pixel gets drawn on the PlayStation 2. Okay? Don't tell Sony I'm showing you this. Okay, so we set up, we do all this stuff, rasterization, registers feed through into all these different bits. Alpha blending. Where does alpha blending happen? RGB, memory interface. So stuff comes through, we write, yeah, that makes sense. Alpha blending comes back in. Alpha test. Now, alpha test, we haven't really thought about as a register. I don't think that matters, but maybe it does. Formatting, whatever. Cool. Texture mapping. Textures are mapped to pixels. The pixel color determines the texture function of texture. RGBA value is read from memory block. RGA value calculated by DDA. RGBA value read from memory block. A, alpha, it's there. Anti-aliasing, we don't care about. Fogging, we don't care about. Pixel test. Whether to draw a pixel is based on XYZ RGBA, blah, blah, blah. Oh, these kind of tests. Okay. So whether to draw a pixel. So this also shouldn't matter, right? This is on or off. That's fine. Alpha blending. Blending the RGB value of a pixel, RGB value of a frame memory is implemented according to the alpha value. Blending the RGB value of a pixel, RGB frame is implemented according to the alpha value of the pixel or the alpha value of the frame in memory. That sounds promising. Maybe our alpha test is looking the wrong way, right? Maybe we should be looking at the alpha of the incoming pixel rather than the outgoing pixel, I guess. Interesting. GS primitives, blah, blah, blah. This is all cool. Love it. Okay, so alpha blending enabled. We have alpha blending enabled. That's good. Context, fix, sure. So we have this, I don't know, it doesn't really matter. Texture mapping on, blah, blah, blah. Outline of drawing process. Prim register, initialize, set vertex information. Cool. This is fine, we're doing this. Vertex kick, yes. Drawing process. Cool. So this is all the stuff we know how to do, right? This is the stuff we're doing. Drawing control and without changing the vertex string order. Operations like normal clips become easy. Vertex information written to XLT. Polygons not drawn. Yeah. This is a cool thing. We're going to use this. Change your drawing attributes from PR mode. Yep. Cool. We don't use PR mode. No. If we did, this could be a candidate, but we don't. A sprite consists of two pieces of vertex information, but it only needs one piece of vertex information for the Z coordinate and fog value because there's no depth. Okay, that's cool. Primitive drawing rule. This stuff is super nerdy. If you love analog signal generation, holy crap. This literally details how each pixel is generated, and it actually treats pixels as points, as, you know, like, yeah, points in a grid rather than like a filled-in square, which they're definitely not in the context of like an analog signal, right? Prim register, yeah. Big time with you. Alpha blending attributes. So this is interesting, right? Alpha 1, 2. This is almost certainly what we've done wrong. Test and alpha. And FBA. And PABE. Okay, let me make a note. Where's my pen and paper? Where's my... let's go. So... Alpha test PABE FB. Okay, so we can go look these registers up now in the big list at the end. So, where are we? So these are the privileged registers. These are the GS registers. So we're starting with PABE, probably. Test. Test comes first. And this just alpha value to be compared and referred to. See, this is interesting, right? This says when the alpha test fails, only update RGB. But that's more for... Okay, I don't think this is it. Interesting, but I don't think this is it. Where are we? PABE. PABE. PR mode cont, PR mode, prim, PABE. Alpha blending control in units of pixels. Alpha blending control in units of pixels. So if it's performed, that means alpha blending is off for the pixel where the A value is MSB equals 0. Ooh. So could this be it, right? This is saying MSB equals 1. I mean, this is just like some weird masking thing, right? I don't know when you would use this, but let's have a look. So we set up our drawing. We never write this. We never write to PAB, right? This is 49. Let me run and just double check. We're going to read some buffers here. I know this is everyone's favorite thing, right? We're going to turn trace logging on. We're going to read some buffers. So where are we? Let's go to debug level. We're going to turn this to trace level. Cool. Okay, let's read some buffers. So we set up our drawing environment, blah, blah, blah. We're looking for a 49 in here. 47, 47. Actually, it might be in the first frame, hey. Because we do a bit of initial setup. But nothing that would set 49. Register 49. No. Okay, so this should just stay default, which I'm guessing would be 0, but maybe that's a dud assumption. This is a candidate. I don't think this is it. FBA will be next. FBA, alpha correction value. These registers set the fixed value of alpha when writing the frame buffer. So the alpha value, so this is the alpha that actually gets written to the frame buffer. And this controls the MSB. So this is to do with that other register, right? These allow you to do funny masking things. I don't think so. Alpha blending settings. This seems more likely. And this is 42. So do we set 42 anywhere? 47, 1A, 1B. We never set 42. Never set it. Okay, so CV, A minus B times C, right shift by 7 plus D. C is the input alpha value. C is the input alpha value. So we have a 2-bit number, specification of input alpha value, C. Each item, so you can control what A, B, C, and D are. So this is a fixed formula, but which values actually A, B, C, and D take? So they can be the RGB value of the source, RGB value of the frame buffer. So input color value, RGB value of the frame buffer, RGB value of the source, RGB value of the frame buffer, RGB value of the source, plus D. So I guess plus 0, right? Plus 0 is good for this. So A minus, why minus B? Why minus B? Do we do source minus, or do we do frame buffer minus source times alpha right shift 7 for whatever reason? I don't know why we right shift. Is above fix. Fixed alpha when the value of C is above fix. Okay. At 128. So 1.0 is 128. So this is why, right? This is why we have, if we go to like planet, this is why when we're trying to draw things like fully opaque, we use this. This is 128. This is 1.0 as far as our float alpha is concerned, right? This is how the fraction is treated. So let's play with these values. Let's just do it, right? Where did that go? Where did I go? Alpha, literally the first one, 42. So register 42. Let's go draw 2D lure. When we draw text try, I guess we'll add it in here. Why not? Before we set the prim, let's go gif alpha. And this has, so we'll go, oh boy. So we'll go A, B, C, D, and we won't set fix to anything. Refer to when value of C is above fix. So maybe we'll set fix to like 255. Sure. So A, let's go. A is 0. B is 1. C is alpha value of the source, which is 0. D is nothing, 0. No, D is, sorry, 0, 1, D is 2, and then fix are going to go 255. Cool, and so we define setting a new register. Let's go function gif alpha b a b. Let's go buff a b b c d fix push. So we push. The first byte is a combination of these things. So, and the first int is just a combination of these things. So it's a plus 2 times b plus 4 times c plus 8 times d, right? Because this comes in at the second bit, this comes in at the fourth, so shift by 2, shift this by 4. Hold on, this should be 4. Sorry, I'm at a factor of 4, so this should be 4, this should be 16, and this should be shift by 6, so 2 to the 6, so that's 32. Is that right? 64. That doesn't feel right. Let's just see what we get. And then b push int fix. What happens? It never completes its draw because we need to go in and say that there is actually this extra thing, 6. 6 of these things instead of 5 of these things, right? And it still blows up for whatever reason. Because we never actually... never actually set this thing properly. We never actually set that thing properly. I forgot an important part of the equation. Cool, so now we go into gs, gs.lua, ps2const.lua, there we go, registers, alpha is gonna be 0x42, I think that was it, right? 42. Now we're good, now we're cooking with gas, now we're setting this thing properly. Okay, we're still not quite there, but we're getting closer, right? First frame, all this extra crap, and then 42. You in here somewhere? I did hex 42. Alpha. Reg text 2. Yeah, no, this looks good. Why isn't this working? Why isn't this working? So all this stuff gets drawn. We do this thing 6. 1, 2, 3, 4. 6. 1, 2, 3. What are you? 16. 16. We should see a 4, 2 in the bottom here, right? And we don't. This says 6. 1, 2, 3, 4. That's not right. That's just not. That's just plain incorrect. Oh, hold on. Oh no, yeah, no, AD, yeah, that's fine. So this is okay, right? This is okay. We come in here, we've got all this stuff. These are good. But the minute... So if I do this as well, this is good. Right, this is all fine. This is a nice big juicy first packet. But the minute I change this number to 6, things get kind of wacky. This first packet isn't quite as meaningful. And it looks okay. This looks better. We're uploading the textures. 6. 1, 2, 3, 4. No, see, this is wrong. We're overwriting some stuff here that we shouldn't be. I think I've got to dig into this and work out what's going on. There is something rotten. Okay, This has gone terribly. This has gone horribly. I feel like all I've done this stream is uncover problems for future Tom to solve. I'm pulling at threads here, right? But this is why it's important to do this. This is why it's important to consume your own engine and consume your own code. So what have we discovered? We've discovered that transparent textures do not work. Okay, let's write an issue. Transparent textures broken. Unable to render transparent textures. Inconsistent texture coloring behavior in fast 2D renderer. What is it? Draw2d.lua 215. N reg n something going wrong when we try and set the number of loops to 6. I'm not convinced it's actually possible, but it should be, right? It should be good. Bug, graphics. I guess I could try it on hardware as well and just double check. This is going to be in my project. It's going to be part of the sprite-based renderer, and we're going to submit it. Beautiful. All right, and I'm going to have to call it there. That was a really frustrating stream. Thank you for everyone who came along for the ride. I'll try and fix some of this stuff up, and then next stream, hopefully, or maybe next stream I'll just devote entirely to clean up of this code and poking it around a bit. But we're going to uncover bugs. There's going to be weird issues to solve. I'm not going to throw my viewers onto anyone today. If you're watching on YouTube, thank you very much for tuning in. And for everyone on Twitch, I'll catch you next time.